A machine the size of a small car is 15 billion miles from home, and it is running on less than half the power it launched with. It loses another 4 watts every single year. 8 of its 10 instruments are already dark, and only 2 are still sending anything back. We're used to thinking the edge of the solar system is a cold, empty line where the sun's wind just quietly fades out. Voyager 1 crossed it and hit a wall hotter than the surface of the sun. Tens of thousands of degrees, in a place that should sit near absolute zero. The plasma got denser the moment it left the sun behind, not thinner, and its magnetic field pointed the wrong way entirely. Voyager 1 is the only object that has ever been out there to measure any of this, and it is running out of power before it can tell us what it means. It was never supposed to get this far. Voyager 1 launched in 1977 on a 5-year mission, a quick tour past Jupiter and Saturn, and then, as far as anyone planned, nothing. It flew past Jupiter in 1979 and Saturn in 1980, and instead of going quiet, it just kept going. For the next 32 years, it fell outward through the sun's territory, toward a boundary no spacecraft had ever touched. Everyone expected that boundary to be an ending, a place where the solar wind thins to nothing and simply lets go. Voyager didn't find an ending. It found a wall. The gas pressed up against that edge sits at 54,000 to 90,000 degrees Fahrenheit, hotter than the glowing surface of the sun itself. And yet, that same wall, hotter than the sun, would read as cold on any thermometer we own. The particles out there are spread so impossibly thin that almost none of them ever strike anything. Temperature without heat. A fire with nothing left to burn. There was just one problem with measuring it. Voyager's plasma sensor had died back in 1980, so the probe crossed the most important border of its life, half-blind. But the team found an answer, by accident. A storm on the sun, launched years earlier, finally washed over the boundary and made the plasma ring like a struck bell. The pitch of that ringing gave away the density of the gas, and the number that came back was interstellar. That was how we learned Voyager had left in 2012, not by seeing the wall, but by hearing it hum. There was a second sign, too. In a single day, the storm of particles streaming off the sun, the ones that had surrounded Voyager its entire life, dropped almost to zero. And in their place, cosmic rays from deep in the galaxy shot up, radiation the sun had been shielding it from for 35 years. In one day, Voyager went from swimming in the sun to standing in the galaxy. The bubble of the sun's weather simply gone. Almost nobody believed that at first. The scientist who read that hum, Don Gurnett, brought the number to a room of colleagues and was, in his own words, politely ignored. Some of them laughed. The idea that the most famous spacecraft in history had slipped out of the solar system a year earlier, unnoticed, was almost too strange to accept. It took months of argument before the number won, and the instruments that heard it are the same ones NASA is now switching off, one at a time. Inside the solar system, one rule almost never breaks. The farther you go from the sun, the emptier space gets. Near the planets, the solar wind is thick with particles. Past Pluto, it thins out. By the outer edge of the sun's bubble, it is very nearly a perfect vacuum. 40 years of Voyager data said the same thing the whole way out. Keep going, and it keeps emptying. Then Voyager crossed the line, and the plasma didn't thin. It got denser, by something close to 40 times, exactly where the map promised it should vanish. The far side of the boundary is packed tighter than the near side, as if the whole galaxy were leaning inward against our sun's little bubble. And this wasn't a fluke of one spot on the map. When Voyager 2 crossed 6 years later, heading in a completely different direction, it found the same impossible jump waiting there too. Picture the edge of everything the sun touches, and instead of fading into nothing, it thickens, like the underside of water seen from below. And it isn't quiet out there. When a big enough storm erupts on the sun, the shock wave takes about 1 to 2 years to travel all the way to the edge. When it arrives, it slams into that dense wall and sets the whole interstellar sea shaking. Voyager has felt those tremors roll past more than once. Pressure fronts moving through the dark long after the sun that made them has forgotten. It means the quiet at the edge of the solar system was never really quiet. It was a shoreline with waves. 2 impossible readings now. A heat that won't warm, an emptiness that fills up, and both of them come from a spacecraft down to its last 2 working senses. There was one prediction the scientists were most sure of. Out beyond the sun's reach, the galaxy carries its own magnetic field, tilted at its own stubborn angle. Cross from the sun's field into the galaxy's, and the direction should swing hard, like a compass needle yanked toward a new north. For months before the crossing, Voyager rolled onto a kind of magnetic highway, where the field lines lined up and pointed the way out. Then it crossed, and the needle barely moved. The magnetic field on the galaxy's side pointed almost exactly the way it had on the sun's side, an alignment nobody predicted, and nobody has fully explained in all the years since. The galaxy's field and the sun's field are shaped by completely different forces on completely different scales. There was every reason to expect a sharp turn. It is still one of the open arguments out here, with no answer everyone agrees on. That strange alignment is part of why scientists still argue whether the sun's bubble is a round ball or something stretched and folded, more like a croissant in the galactic wind. We are standing inside it, and we still can't see its outline. And this isn't just a puzzle about shape. That magnetic seam is part of the shield, the thing that deflects the galaxy's radiation before it reaches the planets. How the 2 fields lock together helps decide how much of that radiation gets through to us down here. Voyager is telling us the wall that protects Earth is stranger and leakier than the models drew, and it can't tell us how much that matters before the power runs out. Which is exactly the problem. Voyager runs on heat from decaying plutonium, and that heat fades a little more every single day. At launch, it made about 470 watts. Today, it is under half of that, and dropping by roughly 4 watts a year. Which means every year, the team has to decide what to let die. Over the years, they have switched off camera after camera, heater after heater, instrument after instrument. Now, even the tiny hydrazine lines that keep Voyager pointed toward Earth are approaching freezing. And it gets stranger than just switching things off. A while ago, the thrusters that keep Voyager aimed at Earth began to clog, grain by grain, threatening to leave it pointed at nothing at all. The only fix was a set of backup thrusters that had sat frozen and unused since 1980, dead for more than 40 years. Engineers warmed them, held their breath, and fired them. and against every reasonable expectation, they woke up. None of this was in the manual, because there was no manual. Nobody had ever flown a spacecraft this old, this far, this cold. Every choice now is a trade. Warmth for data, one more year of holding off the silence for one more instrument going dark. Then, on February 27, 2026, Voyager did something it has done for decades. It rolled to point itself. And its power sagged, close enough to the edge that it nearly tripped the one switch no one wants, the automatic fault system that shuts the whole craft down to protect itself. At 15 billion miles, clawing back from that could take days if it worked at all. So, on April 17, 2026, engineers made the call and switched off an instrument that had run without a real break since 1977, almost 49 years. That left 2. And this is a machine that is already forgetting how to speak. For 5 months, not long ago, its signal turned to nonsense, a single failed memory chip scrambling everything it tried to say. Think about what saving it took. Finding one broken piece of memory smaller than a fingernail on a computer built in the early 1970s from 15 billion miles away, and writing new instructions to steer around it. But they got its voice back. Later this year, it crosses a mark no craft has ever reached. One full light day from home, so far that its own signal now takes almost an entire day to arrive. NASA's next move is called the Big Bang, one risky power-saving overhaul that could buy Voyager another year. Whether Voyager keeps speaking at all now rides on maneuvers like that, run blind across a day-long silence, with no way to know if they worked until the answer finally crawls home. And the strangest part is this. Voyager has left the protective bubble of our sun, but it may not have reached pristine interstellar space yet. Everything it has found, the wall, the density, the field, happened at the edge of the sun's influence, not the edge of the solar system. Even the interstellar space it did reach may not be the real thing. As of 2026, many researchers think Voyager is still sitting in a kind of shallows, a stirred-up zone where the sun's dying wind and the galaxy are still tangled together. The pure, undisturbed space between the stars is further out still, and the probe will almost certainly run silent before it ever arrives. And that edge isn't even fixed. The whole solar system is drifting into a new patch of the galaxy, and the boundary Voyager just mapped is already starting to move. The edge was never a place, it's weather. The true outer shell, the Oort cloud, is so far away that Voyager will not reach its inner edge for about 300 more years. It will take roughly 30,000 years just to pass all the way through it. That is longer than humans have had writing, and the machine will have been silent for almost all of it. Because one day, in the middle of a measurement, the power will slip past a line it cannot come back from. There will be no explosion and no last word. When it goes quiet, that will be it. There is no second probe out at the edge, and none on the way. No backup listening, nothing built to finish the sentence. But Voyager will still be carrying something. Bolted to its side is a golden record, the sound of rain, of a heartbeat, of human voices, and images of who we were, meant for whoever might find it in some unimaginable future. The machine will fall silent in the 2030s. The record is designed to survive for perhaps 1 billion years, so the half of Voyager that dies is the half that was listening to the galaxy, and the half that survives is the half still trying to speak to it. Long after the last person who built it is gone, it will still be out there, holding a snapshot of a species that once reached past its own front door. And after that, 3 impossible things. A heat with no warmth, a sea flowing the wrong way, a field that refused to turn, will keep riding outward, unanswered, on an antenna that can no longer tell anyone what it knows. We built a thing that reached a place we still cannot explain. And we are going to run out of machine long before we run out of questions. There is more to explore. See you beyond the stars.